Alright, so now we're going to look at example 4. We're continuing from our last video on solving systems with inverse matrices. We looked at 2 variable systems. Now we're going to look at 3 variable systems. So we're going to have this system 2x plus y minus z is equal to negative 16, 3x plus 4y minus 2z is equal to negative 23, and x plus 6y minus 3z is equal to negative 17. We're going to follow the same steps. We're going to first write an equation matrix, so we're going to go 2, 1, negative 1, 3, 4, negative 2, 1, 6, negative 3, and that now instead of just xy, we're going to have x, y, z equals negative 16, negative 23, and negative 17. Now in the last few examples, we could have used our calculators to find our inverse matrix and our determinants. That's exactly what I would suggest doing with any system that's 3 variables. So to find our inverse matrix, all I did is I plugged it into my calculator. So my inverse matrix this time is going to be 0, 3/7, negative 2/7, negative 1. In fact, I'm going to give myself a little bit more space writing down here. 5/7, and negative 1/7. And then I'm going to have negative 2, 11/7, and negative 5/7. And again, we can use our calculator to do step 3, where we multiply our inverse matrix by our matrix B, our really constant matrix. So step 3 is happening here. I did just that. I used my calculator, and I get the following matrix back. I get negative 5, 2, and 8. Which means the solution to this system is the point negative 5, 2, 8. Alright, let's look at example 5. We have the system negative x plus 5y minus 3z equals negative 40, 7x minus 2y minus z is equal to 27, and negative 2x minus y plus 6z is equal to negative 5. So let's write our matrix equation. We're going to have negative 1, 5, negative 3, 7, negative 2, negative 1, negative 2, negative 1, 6, times xyz equals negative 40, 27, and negative 5. So again, I would just use my calculator to find my inverse matrix. So our inverse matrix is going to be 13 over 154, 27 over 154, 1 over 14, 20 over 77, 6 over 77, and 1/7. And then the final row is 1/14, 1/14, and 3/14. So now step 3, if we multiply this by b, -40, 27, -5, which again, I would just go and use my calculator. Make it easier on ourselves. We're going to get 1, -9, -2, which means our solution is 1, the order triple, 1, -9, -2. So let's do example 6, and then I'll sum up what we've been doing. So example 6, final example, we're going to have the system -4x minus 3y plus 5z equals 8. Our second equation is going to be x minus 2y minus 13z equals -29. Our last equation is 5x minus 9y plus 2z equals 53. So our matrix equation is going to be -4, -3, 5, 1, -2, -13, 5, -9, 2 times xyz equals 8, -29, 53. So again, I'm just going to use my calculator to find my inverse matrix for step 2. My inverse matrix is going to be -121 over 690, -13 over 230, 49 over 690. My second row is going to be -67 over 690, -11 over 690, and not over 690, over 230, and -47 over 690. And lastly, my last row is going to be 1 over 690, -17 over 230, and 11 over 690. Now again, I'm going to just use my calculator to do step 3, where I multiply this by my constant matrix by b. So 8, -29, 53. I don't want to kill myself trying to figure this out. I don't want to stress myself out too much, is really what I mean. So now when I do that, the resulting matrix I get is 4, -3, 3, which means my answer, my solution, is the order triple, 4, -3, 3. And that's the end of example 6. Now we could have also done this process for all of the examples using our calculators, still writing the steps that I put here in examples 4, 5, and 6. But I would say if you have a two variable system, work it out by hand. It's really not that hard. It's when we get into systems that have 3 or more variables where it gets more difficult. So that wraps up the lesson. We've only got a few more left of this unit.